publish all the results.
Wait, let me check, sir.
I'll show all the results, share all the results with you. So see, in the
Yeah,
chapter
sir.
work
I
and
only see for maths.
okay, fine. So I'll be sharing for science also. See, for work and energy, what all we have to do: work, energy, and power. So basically, we have done up to now, we have done what is work, and we defined work as force, the product of force and displacement. We also studied about positive work, zero work, and negative work. So these were the three types of work that we had discussed up to now. Then in the last class, we discussed about potential energy and kinetic energy, right? So we discussed the potential energy, and there were various forms of the various types of potential energy. For example, we discussed about the gravitational potential energy. We discussed about elastic potential energy. So there are different types of potential energy. Out of that, we have to study gravitational potential energy in detail. So gravitational potential energy, the formula for calculating it was mgh, where mg represents the force and h represents the displacement in the vertical direction. Okay. So this was the potential energy. Then we did kinetic energy. The formula of kinetic energy is given by 1 by 2 mv squared, where v represents the speed of the particle, m represents the mass, so it represents the kinetic energy of a particle. Then we also did a relationship between work and energy, that work and energy, they are interconvertible, and from there we get to know the work energy theorem. So this is a very important concept, work energy theorem. Okay, so the work energy theorem, it states that the amount of work done is equal to the change of kinetic energy. This is also called work energy theorem. So it states that the work done is equal to change of kinetic energy. This is the statement of the work energy theorem. And how do we configure it? So analytically, we obtain the relationship between, we obtain the work energy theorem as, since work is defined as force into displacement or force times displacement. So we obtain the value of displacement from the kinematic equations of motion. As you know that the kinetic equations of motion, they state, first one is V equals to U plus AT. Then you have S equals ut plus 1 by 2 at squared, and then you have v squared minus u squared equals 2as. So these were the three kinematic equations of motion. So out of this, we will be utilizing the third equation of motion. From the third equation of motion, we can obtain the value of displacement. Okay, so just by rearranging the terms, if I transpose this 2a to the other side, we get here v squared minus u squared by 2a equals to s. Okay. So substituting this value of s over here, and for in place of force, if we substitute ma, and in place of displacement, we substitute v squared minus u squared divided by 2a. Okay. So understood this substitution, how we obtained this formula? In place of force, we put the value of the force, which state that force is mass times acceleration. At the place of displacement, we put the value of displacement from the third equation of motion. Okay. So as you can see, the acceleration cancels out, and by multiplying m in the brackets, we have mv squared minus mu squared divided by 2. Then separating the terms, we get 1 by 2 mv squared minus 1 by 2 mu squared. since mv squared represents final kinetic energy and mu squared represents initial kinetic energy, therefore our work done is equal to the change of kinetic energy. Okay. So this is a very important concept here, that our work done, whatever work is being done, work done is equal to change of kinetic energy. Okay. Understood this? Yeah, Neil, you got this?
Yes, sir.
Okay. So if I want to find out the change of kinetic energy, I must compute the initial kinetic energy. The initial kinetic energy is calculated by the formula 1 by 2 mu squared. Then I should compute the final kinetic energy. And the final kinetic energy will be given by 1 by 2 mv squared. And therefore I can compute the change of kinetic energy. So change of kinetic energy will be given by final kinetic energy minus initial kinetic energy. Right? And this is the formula that we just derived. That work done is equivalent to the change of kinetic energy. Okay. So change of kinetic energy is equal to final kinetic energy minus initial kinetic energy. Now, on the basis of this, we will try to solve one of the problems. Let's say this will give you a more understanding or deeper understanding of work and kinetic energy. Okay. So let's try to solve this problem. So with all the formulas, you will try to solve this problem. Everywhere you have to use the SI system of units. Okay. So let's see the question and solve this. Okay. So I hope this question is visible to everyone. Yes. Chavan, Harini, Neil, everyone
Yes,
can see the
sir.
question.
Visible.
Okay. Okay. So start
Yes, sir.
solving.
Sir, how much are we taking gravity as?
There is no role of gravity.
Oh, yeah.
Okay, so have you obtained the answer?
Find the work done. No.
Yeah. Rikshit, are you getting? Rikshit? So this question will revise all your concept from the even from the previous chapters. Okay. So see first part. How do we compute the first part?
Half mv square.
First, yeah, work done will be equal to 1 upon 2 mv square. So half mv square that will be equal to the work done. So that's quite easy. You can compute your work done. So the first part if you are computing, so work done will be equal to half mv square. Okay. So
Sir,
who all
wait.
have
Sir, don't give the answer.
yeah, I'm not giving. Siddharth has given answer as 150. Then okay. Okay, Siddharth is Rikshit, you are not able to talk, so please message your answer in the chat section. Okay, whoever has obtained the answer, message in the chat section. Only Siddharth has given one of the answers. You just need to substitute the value. Substitute the value here 1 by 2. Multiply mass, which is 60. Multiply V squared. V is 5. So square of 5. So how it comes? See, cancel this, it becomes 30. You have 30 multiplied by 5 squared, and 5 squared is 25. Okay. So what is the answer? Yes, what is the answer?
750.
750. Is it plus 750 or minus 750? Check out, are you getting plus 750 or minus 750? Neil, are you getting the answer?
Yes, sir, I'm trying, sir.
Okay. So answer is 750, but just check, is it positive or negative? The formula for work done equal to change of kinetic energy. It was 1 by 2 mv squared minus 1 by 2 mu squared, right? So our final velocity of the cycle is 0 since cycle finally comes to a stop. So the final velocity is 0. So we put here 0 minus 1 by 2 mass, which is 60, and multiply u squared, which is 5 squared. So just by calculating, you get minus 750 joule. Is this correct?
Yes.
Okay. So here the work done to stop the cycle is minus 750 joule. Now, if cycle stops after traveling a distance of 3 meters, so find the force applied.
250 Newton.
50 Newton,
250 Newton.
250 Newton. Yes. From here, if you apply the formula of work as force times displacement, so we already know force, the work done we have obtained as minus of 750. So this should be equal to force times displacement. So therefore, force multiplied displacement, which is 3, should be equal to minus 750. And hence, the force should be equal to, from here we obtain the force, and it implies that the force should be equal to minus 250 Newton.
Sir, but when we break a cycle, isn't it supposed to be final velocity? Like it comes to rest?
Yeah, what happens? Final velocity is 0. That is when it comes to rest.
Okay, so 5 meters per second is the initial velocity.
Initial velocity. It is initially traveling with 5 meters per second. And he applies brakes so as to bring the cycle to rest. Okay. Hence, the work done by the brakes to stop the cycle will be minus 750. Okay. So, everyone has understood this part A. Part B also we have done. Okay, part B is only the force applied. So, force applied by the brakes is minus 250. Okay. So, the force applied is minus 250. Retardation of the cycle. You have to compute the retardation. And retardation is also known as negative acceleration. So, for this, you need to compute the acceleration, which will be given by force by mass. Right? Siddharth, are you getting? Yes, Siddharth.
Yes, sir.
Okay. Did you get the acceleration?
No, sir.
No. Compute the value of acceleration. Neil, did you get the acceleration?
No,
We
sir.
get the acceleration by using the formula force is equal to mass into acceleration. Mass times acceleration. By putting the value of force, by putting the value of mass, we will be able to compute the value of acceleration. Retardation means acceleration. Okay, retardation is negative acceleration.
Sir, what does retardation mean? Like force or acceleration?
Retardation means acceleration. If the acceleration is negative, we also call it a retardation.
Sir, I got it.
Okay. So who all have got the answers? Okay, so one of the answers I think someone has sent. Okay, Siddharth has sent the answer of acceleration. Chavan, did you get the answer?
Yes, sir.
So if you have got the answer, message in the chat section. Neil, did you get the answer for acceleration?
Yes, sir.
Okay. So it is force by mass, which we get as acceleration. Force is minus 250. So minus 250 divided by acceleration divided by mass, which is 60. So therefore we get acceleration as minus 25 by 6. Okay. So acceleration is minus 25 by 6. And time taken by the cycles to stop. Now, can you compute the time? How? We know the value of acceleration. We know the value of initial velocity. We know the value of final velocity. So from here, we want to compute time. We know initial velocity was 50 meter, initial velocity was 5 meter per second. Final velocity was 0. And we also know the value of acceleration, which is minus 25 by 6. So can you tell me how much time did it take for the cycle to stop? And which equation of motion will you utilize?
The A equals to V minus U by T.
A equals to V minus U by T.
Yes.
Okay. Okay. So using that formula, using the formula of acceleration or by using the first equation of motion, tell me how much time will it take for the cycle to stop?
So 6 by 5.
6 by 5.
Yes.
So 6 by 5 is 1.2. So that's 1.2 second. The cycle will take a time of 1.2 second to stop. So this question actually it carries topics. It carries everything from all the chapters. It carries everything from the chapters of uh, it carries everything from that motion, force, and work and energy. All the three chapters they are included in this question. Okay, let's have a similar question. A question similar to this. I think everyone has understood. Harini, Rikshit, Siddharth, and Neil. Everyone, have you understood?
Yes.
Yes, sir.
Okay. So in the next question, I'll just give you the question and wait for the answers, and you must get your correct answers. That is also a similar problem, but having a little bit of different things. But again, a similar logic, a similar thing. All right. So let's. So we have here a bullet of mass 200 gram was fired from a gun It strikes a wooden board and penetrates it to a distance of 5 centimeter. So find the work done by the wooden block if the bullet comes out of it with a speed of 'Kay. So I think now you can start doing. You have the question. A bullet of mass 200 gram was fired from a gun with a speed of 300 meter per second. It strikes a wooden board and penetrates it through a distance of 5 centimeter. Find the work done by the wooden block if the bullet comes out of it with a speed of 50 meter per second. It requires just the similar logic. Similar questions are placed here.
Sir, we need to calculate kinetic energy or
Yeah.
do we have to use MGH or kinetic energy?
See, MGH we use only when there is a gravitational work done.
Okay.
Okay, if there is a work done against gravity, so then we use MGH. So everyone should be able to obtain this first one. You find the force applied by the block on the bullet. Okay. So I think few of you have said the answers. Send your answer, whatever you have done. Okay. So I think you can do, first of all, you can find out the work done also. That's quite easy. You can also find out the acceleration and the force applied. Both of them, they are similar to the previous question. So I don't think that there will be any problem in doing these parts. Siddharth and Kaushik. Yeah, Neil, have you got the answers? See, Chavan Kaushik has given the answer, but Chavan, keep in mind we have to use the SI system everywhere. And here the mass is given in gram, not in kilogram. So you need to convert your mass 200 gram to kilogram. That is your first step. See, for the first one, what all things are to be calculated? Mass is given as 200 gram. So we convert this to kilogram and mass will be equal to 0.2 kilogram. Here we know the velocity, but this is the initial velocity of the block of the bullet. So initial velocity u we write as 300 meter per second. Then since the block was initially moving with this speed 300 meter per second, so therefore initial velocity is 300 meter per second, and it strikes a wooden board and penetrates it through a distance of 5 meter. So 5 centimeter. So since this is the displacement 5 centimeter, we write this displacement as, but this is in centimeter, so we convert it into meter, which will be 0.05 meter. Then find the work done by the wooden block if the bullet comes out of it with a speed of 50 meter per second. So this is speed 50 meter per second. This is the final velocity v. So final velocity v is 50 meter per second. Okay. So if we want the value of acceleration, we can directly use the kinematic equations of motion. Okay. Either you can go the way we went in the first question. In the previous question, the way we did, in that way also you can do, or we can directly use the kinematic equation as v squared minus u squared equals 2as. Okay. So just by putting the values, we can compute the value of acceleration here. V is 300. So we put here 300 squared minus u, which is 50. So we put here 50 squared divided by 2s. So 2 times of 0.05 will be equal to acceleration. So rest the calculations are easy. You can put here 90,000 minus 2,500 divided over 0.1 equals acceleration. So just subtract this and you get the value of acceleration. Subtract and divide. So 90,000, if you subtract 2,500 from 90,000, you will get 87,500. You will have 87,500 divided by 0.1 will give you 8,75,000 meter per second square. Okay. So did anyone get this answer? Harini,
Yes, sir.
where did you went wrong?
So I didn't use this formula to find acceleration.
Okay, so even if you go the other way, like we did in the previous question,
Sir,
so
I
then
did
also,
work equals to force into displacement, and then I found force, and then I calculated the acceleration.
okay,
Force
so
plus mass.
in that way also it will be the same thing. Okay, if you
Alright.
compute the work done, see, Work done we compute as the change of kinetic energy. So we obtain here work done equal to 1 by 2 mv squared minus 1 by 2 mu squared, right? So this was the first step. We wanted to compute the work done. So if you compute it this way, 1 by 2 times mass is 0.2, multiply your initial velocity is 300, so square of 300 and minus 1 by 2, again mass is 0.2, multiply, sorry, your final velocity is 50, so you have to put here 50 and initial velocity is 300. So it has to be put up like this. 0.2 multiply initial velocity, and your initial velocity is 300. So you put here 300 squared and here you put 50 squared. Okay. So this will be just, I think now you can compute. So I think the mistake that Harini made was that Harini, you did not take your initial and final both the velocities.
No, sir.
Okay. So anyone else? Neil, are you able to get this?
Yes, sir.
Chavan. Okay, Chavan.
Yes, sir, I understood, sir.
So, but you did not get the same answer, right?
Yes, I forgot to convert it and stuff, sir.
So remember, always everywhere you have to use the SI system of units. Okay. Once you have used the SI system of units, so after the SI system of unit, so after you have used the SI system of units, then only you can get the answer. Either you use this formula or you went in the previous question, the same thing will happen. The same sequence, your answers will remain the same. So I'm waiting for you to compute the calculations, to compute it or complete it just by changing the value. So I'm just changing one of the value so that you will perform the complete question again. Is it all right now? So I'm changing one of the values. You just need to compute the question, complete the question again. So here I'm changing, it comes out with a speed of 100 meter per second. That's the only change. And let me change the mass also. Or okay, initial velocity I'm changing it to 200 meter per second.
Sir, my other class started. I have to go now.
Which other class has started?
I have a chemistry class, sir.
Okay. But do inform to that sir also. Do inform to sir also. Right?
Okay, sir.
Okay, bye. Yeah, Harini,
Yes, sir.
have you got the answer?
So still solving.
Okay, solve it. So either way you compute, that's your wish. Either you compute by any of the methods, you will get your correct answer.
Sir, I got minus 3000 joules.
Minus 3000 joule. Okay, let me check then. Your work done should be equal to 1 by 2 mv squared minus 1 by 2 mu squared. So you can either take 1 by 2 into m common and put here v squared minus u squared. So you will be getting 1 by 2 multiply mass, which is 0.2, and your final velocity is 100. So 100 squared minus initial velocity is 300 squared. So this you will get as 0.1 into 100 squared is 10,000 minus 90,000. So still you get 80,000.
Sir, didn't you change it to 200?
So that 200, that was 200 gram only.
No, sir, you
Sir,
changed
the
it.
speed, sir.
Yeah.
Sir, the speed you changed it to 200 meters.
Yeah,
Okay, the
sir.
speed. Okay, fine. So I need to change this speed, which I made 200. Right? So this was 200 square. It will become 40,000 then. So it's minus of 3,000, right?
Yes, sir. Same.
Okay. So everyone has got the same answer?
Yes, sir.
Now, by using any of the methods, you can obtain the value of acceleration. You can obtain the value of acceleration either by using any of the methods. So work done will be equal to force into displacement. Our work done is minus of 3,000 will be equal to force times displacement. Force is we do not know, and displacement is 5 centimeters. So 5 centimeter will be equal to 5 by 100. So you can get your force. This will be minus of 3,000 into 100 by 5. That will be the force.
So
And
minus
again,
1000.
yeah, if you put force and mass into acceleration, so you'll get your answer. So this will be minus of 3,000 into 20 will be equal to mass times of acceleration. So just by putting the value, you can get your answer. Rikshit, are you getting? I'll give you more questions to practice. Okay, don't worry.
Yes, sir.
We will do more questions from this topic. Work and kinetic energy. Neil, you didn't get any answer?
Sir, I got, sir, but I didn't calculate full, sir.
Okay.
So minus 3 lakhs is what I got. Acceleration.
Minus 3 lakh. Okay. So you can compute your acceleration by any of the methods. Either this way or the same question you try by other method, you will be getting your same answer. Okay. Now, mainly see the last part. So Harenik, how can we solve the last part of the problem?
Sir, we have to find the thickness required. Sir, so what is the present thickness that they give?
Presently, it was
5
5
Yes,
centimeters. So how much more distance is required?
So you can use a formula because we have all the values. So
Mhm.
MVSN. Um. um, Sir,
Say,
we can use V square minus U square equals to 2AS, and then
okay.
we can find distance because we have all the other values.
Yeah, we can use v squared minus u squared equals 2as. This one is for the last one, C part.
And we have to write the V as 0 instead of 100.
Yeah, we have to write here v as 0. And what should be the initial velocity then?
Initial velocity will be it'll be 200 only.
It will be 200. See,
Yes, sir.
there are two ways. If you take 200, so then you will get the complete thickness, right? So if you use here 200, so if you put here 200 squared, you will get the complete thickness. So 200 squared divided by 2a, 2 times of acceleration will give you the complete thickness. Okay.
And then
So
we can
this,
do the complete thickness minus 5.
yeah. So it will be minus of 40,000 divided by 2 times of acceleration, which has already been calculated. Putting the value, you can calculate the value of this total there. So find out the value. Okay, anyone has obtained the answer?
Sir, I got 2 by 3.
2 by 3. Total
Yes, sir.
displacement? Total displacement?
Uh, Total 1 second.
That would be 2 by 3 meter then.
Okay, yes.
2 by 3 meter would mean 0.67 centimeter. But I don't think it's correct. Check it out again.
So acceleration was minus 3 lakhs, right?
Yeah,
So then you have to do 40,000 divided by minus 40,000 divided by 2 into minus 3 lakhs.
yes.
Then if you cancel out the zeros, you will get 4 by 6.
Okay.
Oh, okay, yes, sir. 1 second. Sir, I got 4 by 60. 2 by 30, sir. I mean
2 by
1 by
30, right?
1
Yeah.
by 15.
Yeah, so you get a 2 by 30, and that 2 by 30 would be equal to 0.067. Okay. So out of this, the distance that you already have is 5 centimeter. So subtract 5 centimeter from this. This is 0.67 meter. You can consider this to be 6.7 meter and subtract 5 centimeter from it. So an extra displacement of 1.7 centimeter is required. An extra thickness of, right? So any other problem? So I hope today you have understood this work energy theorem, where we observe that work gets converted to kinetic energy, or work is equal to the change of kinetic energy. Right? Okay. So anyone having any doubt? Not able to understand any of the point? Okay, so Neil, have you understood everything?
Yes, sir.
Okay. So bye everyone. I hope I will send you some of the homework to do along with this. Okay, but do practice these questions also. Bye everyone. Good night.
Thank you, sir.
Bye, sir. Thank you, sir.